again. Researchers would like to know whether the proportion of elementary school children who are obese differ in rural compared to urban areas. Okay. They plan to take a random sample of 800 children from the urban and a different 800 children from the rural. Okay, so there's two samples essentially, both being 800. And they're going to compare how fat they are, essentially. So that's pretty straightforward. Now, suppose that unknown to the researchers, P1 and P2 are both 35%. Describe what the sampling distribution would look like. Right, now, if you know P1 is 35% and you know P2 is 35%, let's show you the theory about what the sampling distribution for the difference between those two would look like. So the sampling distribution, it will have a mean of whatever P1 take away P2 is. So if you take the first guy and you subtract the second guy, since they're both the same, the mean will actually be 0 in this story.
Okay.
So far, so good. Now,
Yeah.
there is a formula for getting the standard deviation. And actually there are, I think there's 3 formulas altogether, but there's 2 common ones. So P1, Q1 over N1 plus P2, Q2 over N2. And that is the one I'm going to try first. You typically would use this formula if the 2 distributions are independent of each other and there's no clear connection. The second formula is called a pooled standard deviation, and that's a different formula, and I'll show you that one if this one doesn't work. Now, P1 happens to be 0.35, and Q1 happens to be 0.65, and there were, I believe, 800 students in the urban group. Now, just by coincidence, or whatever you want to call it, in this story, P2 happens to be exactly the same numbers with the exact same sample size. So you can see here, what we really end up with is just one particular calculation where each pairs or set of numbers are the same. So let's go for the square root. Now, I did say there's 3. I'll tell you about the third one if this one doesn't work. And then I'll try and work backwards for why. I don't think they should use the third one. The third one is a difference formula. And there's no good reason why that would ever be used in this context. So I'm pretty sure I'll never need the third one. And the answer I get is the one that I'm looking for. So it's 0.0238 because they wanted 4 decimal places.
Okay.
So that's it. So if they were doing lots and lots and lots of samples, and we would expect that the mean, the difference between them, the mean would be 0, right? So that's basically half the time it'd be a little bit positive, the other half the time it'd be a little bit negative, but it run about 0 every time, give or take a little. And how much give or take? Basically, the standard deviation gives you an idea of how much away from the mean you would expect. So it's about what, 0.238, so 0.2, 0.4, 0.06, not a lot, right? And then they have a picture. And you basically, if you want to draw this picture, it's a standard shape. right in the middle should be a 0. And then one standard deviation should be 0.0238. And then 2 standard deviations would be 2 of those. And then 3 standard deviations, 3 of those. Since the mean is 0, 1, 2, 3 standard deviations ends up just being that guy, twice that guy, and 3 times that guy. And the ones going this side, well, one of those guys, but with a negative, because you're subtracting it.
Okay.
And then 2 of these guys, then 3 of these guys. And one of those pictures will look just like that one. And they have gone and rounded it off, but that's fine. It's a third picture according to me. What do I mean by that? They've gone and rounded this off to 0.024 for some reason, without telling us, which was not very nice. But that's fine. You need 4 decimal places for the answer, but evidently you only need 3 when you do the picture for no good reason.